In this video series, we're going to focus on solving radical equations and inequalities. And in this first video, we're going to discuss different tips to solving equations and inequalities with radicals in them. Now, the first tip is to make sure you isolate the variable on one side of the equation. And the hint here is that factoring may help. Now, what this means is if you have, let's say, two terms, and I'm going to use all variables here instead of radicals to kind of show what this tip means. If I have, let's say, xy minus, we'll say xz equals 3. I need to isolate the variable on one side of the equation. That's just a general rule for solving. And my x is on one side of the equation. However, these are two unlike terms. One's xy, one's xz. So how am I supposed to get the x out of the unlike terms? And that's the hint. Factoring may help. If I were to factor an x out of both terms, I have x times y minus z equals 3. And now I could actually divide both sides by this parentheses and get the x by itself. So isolate the variable on one side of the equation, factoring may help. And factoring is going to help if you have, I would refer to it as, unlike terms. For radicals, what that may look like, for an example, is if I have 3x plus x radical 2. This 3x, x radical 2, I can't combine them. They're unlike terms, so I'd have to factor out an x from both of them, and then I'd be able to solve for x. This is a tricky one, and this one is something that is very hard to master, but we're going to have to remember for some of our examples. Next is to isolate the radical on one side of the equation and then square both sides. This is if you have only one radical. If you have only one radical, what you want to do is you want to make sure you get it on one side. So if I have, let's say, the square root of x equals, we'll just make it easy and say 2. This radical is isolated on one side. There's no operations with it. There's no addition, no subtraction, no division. It's all by itself. So now I do the opposite operation, the inverse operation to cancel it out. And so the opposite of square root is square. And so I would square both sides to cancel it out. So this is if you have one radical, you isolate it and move everything to the other side. And after it's completely isolated, the radical itself, you square both sides. If you have two radicals, what you need to do is put them on opposite sides. Put one on the left side, put one on the right side. And that just means put them on opposite sides. And then square both sides. And so here I just had one radical, but if I have two, so let's say the square root of x equals the square root of 2x minus 1, they're on opposite sides, and as soon, if I look, well, there's no addition or subtraction. There's no addition or subtraction here. I could square both sides to keep the equation balanced, and I'm left with the square and square roots cancel each other out. X equals 2x minus 1. Now, this is a basic example of what it means to isolate the radicals on opposite sides. If you have two radicals, you want to make sure you put them on opposite sides and square. Now, the more complicated one is going to have another term here, and there's going to be a process that you're going to have to use to make it easier to do. And then, as always, check your solutions. Now, the reason why you have to check your solutions is you're going to sometimes have a solution that is referred to as extraneous solution. And what that means is you're going to get a value for x, but it's not going to be true. It will not work. And so what happens is if you solve for x, you always have to check your answer. Is if you plug it in, you're going to see you're going to get a false statement sometimes. You might get a true statement, which is true. So this always check your solutions is not an option. because sometimes you'll do all the work and get x equals, let's just say x equals 4. But if you plug 4 into the equation itself, you will get a false statement that's not true. And so we're going to see a lot of examples of these, and it'll assist us with understanding what it means to be an extraneous solution. So these are your tips. This doesn't cover everything, but it covers a gist of how to solve the radical equations. So be familiar with the setups before you move on to the example problems.